This is the screencast for section 2.3, example 4, algebraic combinations of continuous functions. So now this may seem obvious to you, but until we have this proven, until we have a theorem that tells us it's true, we can't state it. So now we can. The sum of two continuous functions is still continuous. The difference of two continuous functions is still continuous, etc. The product, a constant times a continuous function, still continuous, and the quotient of two continuous functions, still continuous. And then theorem 7 also states that the composite function of two continuous functions are still continuous. So let's look at example 4 and use theorem 7. Show that y equals the absolute value of x sine of x over x squared plus 2 is continuous. So I see a lot of things going on here. I see a composition function, I see a product of functions, I see a sum of functions, I see a quotient of two functions, lots of stuff. So let's first break apart the composite function. So the exterior function of this composition is the absolute value of x. The interior would be x sine of x over x squared plus 2. And I know there's a lot of ways to decompose this function, but let's stick to something simple for the exterior and a little more complicated for the interior. We know that g of x equals absolute value of x is a continuous function. That's that V-shaped one. There's no discontinuities. We're all set. F of x, though, is made up of a whole bunch of stuff. X is continuous, sine of x is continuous, x squared is continuous, 2 is continuous. Therefore, the product, sum, and quotient of all of those functions is still continuous by theorem 6. So now, since g of x and f of x are continuous, g of f of x, which equals our final function, is also continuous. Now try problem number 33. We again have a function that is a composition, and the inside function is going to be a sum and a quotient of a couple of continuous functions. So let's break apart f of x as the composition function, g of x being square root of x, and h of x being x over x plus 1. G of x is a continuous function. And I know that its domain isn't all real numbers, but that doesn't matter. It is a continuous function. That's all that it needs to be for theorem 7. H of x is a continuous function because the sum, x plus 1, of continuous functions and quotient, the x over x plus 1, are also continuous. So since g of x and h of x are continuous, the composition g of h of x, which is our f of x, is continuous.